Chapter 7: Gases, Liquids, Solids, and Phase Diagrams. Section 7.9: The TQ phase diagram. The TQ phase diagram is the temperature heat phase diagram. Now let's look at one example of water under 1 atm pressure. Pure water undergoes fusion at 0 degrees Celsius and vaporization at 100 degrees Celsius. So over here we have the temperature versus heat for water. First, let's start with a very low temperature. We have ice. Now heat flows into the ice, and that will increase the temperature of ice. You see this line, the temperature increases as heat flows into the ice until it reaches 0 degrees Celsius. This line is approximately linear because the temperature change is approximately proportional to the amount of heat. But why at this point there's a plateau? Very simple. As heat flows into ice at 0 degrees Celsius, the heat does not increase its temperature. Instead, the heat help melt the ice. That's why you see the plateau here. The ice is converted to liquid water as heat flows into the system, and we have a constant temperature fusion process. Now at this point you have 100% liquid, and if heat keeps flowing into this liquid water, again the temperature of the liquid water can increase as heat flows in. And this line is also approximately linear because the temperature change of the liquid water is approximately proportional to the amount of heat that flows into the water. Finally, we reach this 100 degrees Celsius and see another plateau. This is just because from here to here the temperature is constant. The heat flows into the system only to vaporize the liquid water to the gaseous water. So at this point we have 100% water vapor. So after this point you can keep heating up this water vapor. You see another positive slope again. So there are two plateaus in this graph. The first one is the fusion process. The second one is the vaporization process. In the fusion and vaporization process, heat flows into the system but not changing the temperature of the system. Heat flows into system to facilitate the phase transition from solid to liquid, from liquid to gas. Now let's look at the slopes of the TQ line here, here, and here. The reason we have three slopes here, here, and here is because we have the solid phase at the beginning. In the middle we have the liquid phase. On the right hand side we have the gas phase. So what is dq over dt over dq? Again, the slope is simply dt over dq, but what's the physical meaning of this? Remember we said under 1 atm pressure, so assume the pressure is constant. So dt over dq is also dt over dqp, and that's just the reciprocal of dqp over dt. Remember the definition of heat capacity. C is dq over dt, and dqp over dt is cp. So really these three slopes are the reciprocals of the isobaric heat capacity of the water in the solid phase, in the liquid phase, in the gas phase, and they have different values.